Okay, so today's lesson is so easy that I decided to go straight to the your turn questions because we already had our lesson in class. Anyway, it says compare the two salary plans listed by using a graphing calculator, and job A starts with $2,000 with $500 raise every month, and job B starts with $1,500, but they give you a 5% raise every month, okay? So will job B ever have a higher monthly salary than job A? Well, we already know that the answer is A, because if you're just adding by 500 every single time and you were to graph it, it looks like a straight line going like that. But if you were to go ahead and make a 5% increase every single time, then you're basically this is an exponential function, so you're going to be multiplying by 1.05 every single time, remember? And so your graph is going to look like this. And I shouldn't have to explain this part in any more detail because this is the second chapter where we're talking about exponential functions, right? Anyway, so we already know that eventually job B is going to have a higher salary, so let's just go ahead and say will, because we already know that's the correct answer. And then the part 2 of the question is job B will have a higher monthly salary after about how many months, right? Now for this part, we're going to have to use our calculator. And you know what? We're actually going to go ahead and come up with our equation to figure it out. Okay? So first thing we're going to do, we're going to have job A and we're going to have job B. Now I just want to go ahead and start a table. Because what happens with job A is on the first month, they're going to start off with $2,000. Okay? So after 1 month, at 0 months, they're going to start with $2,000, right? And then after they're done with the first month, it's going to be $500 extra, right? So it's $2,500. After another month, that's going to be another $500, so that's going to be $3,000. After another month, $3,500. After another month, $4,000. And then you can keep going on and on and on. For job B though, when you first start, that's 0, right? You're promised to be paid $1,500. After the first month though, you get a 5% raise. What that means is you have to multiply $1,500 by 1.05. And of course, you know, for that, I need to use my calculator. So 1,500 times 1.05. And that's 1,575, okay? So I'm just going to go back and put the number, 1,575. And then when another month passes by, we're going to have to multiply 1.05 to that number. So let's just go ahead and do it. So that'll be 1,575 times 1.05. And so now that's 1,653.75. Okay, so and again, same thing over here, you keep going on and on and on. So this is job B and this is job A. And so we already know that eventually the person who works at job B will make more money than job A. Okay, but then when? Job B will have a higher monthly salary after about however many months. Well, we have to know how to set up the equation to do this. And we already know how to set it up because what's going on? In the beginning, you start off with 2,000 and then you go up by 500. And just like using the regression model, we're going to go into our Desmos calculator and then we're going to just plug in the table. So we're going to plug in two tables, okay? So click on the plus sign table with this. We did this in class. Only thing is you have to start with 0. And then you can keep going. So in the beginning for the first job, how much did you start off with? Let me go back with 2,000. And then you are going to add $500 every single time. Okay? Okay. And so that is just the first job. For the next one, I'm going to add another table because this time we're going to talk about the second job. And when you are at 0 months, they paid you with, for job B, it was 1,500, right? So I'm going to put 1,500. But then after a month, they promised you, something else, right? So that was 1575. Remember our numbers? And then our second number was, let me go back and try and remember, 1653. 1653.75. 1653.75. And of course, you can go on and on and on and on. And so what I'm going to do is I have to keep multiplying by 1.05 to the next number to get the next and next and next. And so we talked about the viewing area, right? So I'm just going to go ahead and change the numbers. My smallest number on the X is 0. I want to get a little bit smaller than that. So start with -10. And my biggest is 4 right now, but I'm just going to change that to like 10. And then for my Y values, my smallest number is 2,000. So you know what? I'm going to go a little bit lower than that. Why don't I just start with like 1,000? And then I'm going to go up as high as, I don't know, the biggest number here is 4,000. So I don't know, maybe I'll just try 5,000. And so that way the graph is more clear. You can already see here that this blue line is just going to be a straight line going that way. Okay? And I know it doesn't look that straight, but still. And then you can already see that this one is going to be like a curve like this. And see, eventually these two graphs are going to meet each other, but obviously not here yet. It's going to be outside of our screen area. But what we're going to do right now is we're going to go ahead and do what we did yesterday in class. Okay? We're going to go ahead and ask the calculator, you know what? This one looks like a straight line. So can you tell me what the equation is? So I'm going to use y, and then the squiggly line. Oops, I'm supposed to use y sub 1 because if you look, the blue ones are x1, y1s, and then the orange ones are x sub 2 and y sub 2. So I'm going to ask it. I think is y is equal to mx sub 1 plus b. Can you tell me what the equation is? And then look, it's telling me. So what is the equation? Y is equal to, m is what? 500, so it's 500x plus, and b is 2,000. Oh, there you go. So they match. So I know that I could safely use this graph, okay? Now for the second one, I'm going to ask the calculator, can you give me the equation? And this is called the regression model, right? So this time I gotta use x sub 2 and y sub 2. Don't get confused. Today we're using 2 tables and 2 equations, okay, to get to the answer. So remember how we talked about we're multiplying by 1.05 every single time? So this is an exponential function. So I'm gonna tell my calculator, hey calculator, we're gonna use the second set of numbers. Can you give me the equation? I think this is a times b raised to the x sub 2 power because it's, you know, it looks like a exponential function to me. And so that is exactly what you do. Okay. Oh, so hey, it totally fits. Okay, so it has to be the correct equation. But you know what I'm gonna do? I wanna make sure that I do this right. So what did the calculator tell me the equation is? Y is equal to, what was A? 1500 times, and what is B? 1.05, right? And then we're gonna raise it to the power of x. When you write the regular equation, you don't do sub 1s and sub 2s, okay? So there you go. Oh, but I need to find the spot where these two lines meet, and that's definitely not here because we cannot have negative 1.166 months, right? Don't forget that the tables that we're plotting here, these are the months, and this is how much money you make per month, right? And so then I have to change my zooming window, don't you think? I'm just going to try and zoom out in this case because I think that will work. And actually, it did because but I'm still going to change my zooming window. This is my answer and it already showed me the answer, so I don't really have to. But just for practice, you know, this is the x-axis. And if you want your window to be from, why do you want the negatives, right? Because it's not like you want to find out how much money you make in negative 100 months. So we can just start with something else. Oh, but wait, where's the answer? Like around here. So I could go up to 100, right? So x-axis. Come on. I will start with like negative 10 and then I will go as far as 100. Okay? And then for the y-axis, same thing. Why would I need any negative numbers? The salary actually just started at $1,500, I think. But how high do I want to go? Maybe I'll just leave it like this. And now when I click on it, oh, I see that. Now I'm going to zoom out a little bit more. I don't know, maybe Y value, I don't have to go that far. Why don't I just say, instead of 40,000, 50,000. Y value, I'm going to change this into 50,000. And see, the reason why I changed the zooming window is because it's so much clearer. I could see it. Okay, so, and then the numbers change too because they give me more detail as I get closer to them. See, if I go far away, they give me 64. But as I get closer, you see how the number changes to 63.95. They give you more detail when you're closer. Anyhow, so what is my answer? At what point do they suddenly pay the same amount? At 63.95 months. And how much are they going to pay? $33,975. Okay, let me see what's going on here because this is a drastically different answer. Oh well. Okay, so I'm looking at my answer and you know that there's no 63.95 months, right? So I'm going to round and I'm going to say after 64 months, okay? So at around 64 months, job B will have a higher monthly salary. So let's check this answer and yes, it is right, okay? So just make sure you round it. Okay, because there's no such thing as 63 point something months, okay? And so of course, I would, if this was homework, I would make you, because it is homework, take a screenshot, and the part that I want to see is obviously this part where you're asking the calculator what the equation is and then you write the correct equation. Same thing over here, okay? And then of course I would like you to plot the points so that way I could see that you did the work. And this is a little bit different because yesterday in class we couldn't just plot it here because it was only one graph. But when there's two graphs, you can find the point where they meet. As you can see, if you have job B now, starting from this point on, you'll make more money. If you had the other job, you know, you're gonna make less. Exponential functions eventually end up getting bigger faster and faster. That's the most important thing you have to know. So what I'm gonna do now, I'm gonna move on to your next question, homework question. Similar homework question, not exactly the same if you see. Alright, so let's see. Determine whether the situation is best described by an increasing or decreasing function and whether a linear or, if you remember, linear means just like a line like this, or exponential regression should be used. Why is the 0 here? Anyway, exponential regression is like this. Then find the regression equation. Okay, so you have to come up with an equation in the end, okay? A barrel of gasoline has an initial pressure of 432 torr. Its pressure was then measured every 5 minutes. So at 0 minutes, it started off with 432 torr, but then after 5 minutes, they measured the pressure again. It's 454. It's getting bigger, huh? And then at 25 minutes, the pressure is now 610. Okay, so it's a good thing that you understand that. And so what they're trying to do over here is they want you to, they want to see if you understand if this is a linear function or an exponential function. If the difference is the same, if you're adding by the same number every single time, then it's a linear function. This means linear. If you are multiplying by the same number, then you know that this is an exponential function. That's why they have these two things for you, but you don't really have to fill it out. You already know the answer. Let's try this. Over here is both 0, but then to go from 432 to 454, what did you have to add? We just have to subtract backwards to figure it out. So you go back number, 454, minus 432. 4 minus 2 is 2, 5 minus 3 is 2, so your answer is 22. Well, then do you have to add 22 to 454 to get 500? You already know that's not the correct answer. How do you know? You just go backwards again. 500 minus 454. So 10 minus 4 is 6 and 9 minus 5 is 4. Oh, what? That's not going to work because if this is a linear function, the difference has to be the same throughout the whole thing. So I don't even have to complete the whole thing. I already know that it's going to be an exponential function, but just in case it's not, let's go ahead and work it out. Okay? So there you go. In order for me to figure out what number I have to multiply to get to the next number, I have to go backwards again. I always go back number, 454, divided by 432, the front number, and then I'm going to put the answer there. I can't do this on at the top of my head, so I gotta go use my Desmos, okay? So it's 454. Oops. Oh, I gotta get rid of everything that I did earlier, right? And then I could just, okay. So now I already forgot. 454 and 432. And that gives me 1.05. Okay, so I'm just gonna go back and put 1.05. And now to figure out if the rate is the same, I need to do it again. This time I'm gonna go 500 divided by 500 divided by 454. Okay, 500 divided by 500 divided by 454. What? Did I do something wrong? 500. That's right. 500 divided by 454. And this time I got 1.10. Uh-oh. So 1.10. Uh-oh, they're supposed to be the same. Let's move on to the next one. Now I got 535 divided by 500. 535, 500. 535, 500. Now I got 1.07. Okay. So you know what? We already know that this is also not an exponential function. But you know what? I'm looking at the difference here and there's drastic changes. But these numbers are kind of similar. So you know what? I'm going to take a chance and see if this is an exponential function. Let me just finish this up just because I'm curious, okay? So 583 divided by 535. 583. I should write this down somewhere else as I do this. 583 and 535. Let me go back to the calculator. So it's 583 divided by 535. And it didn't come out. 583 divided by 535. And so now it's 1.08. Yeah. There you go. It's now 1.08. So you know what? I'm gonna go with exponential because these numbers are pretty similar versus over here. It was 22 and then all of a sudden drastically it changes to 46. And then if you do the next one, 530, that was that. 535 minus 500 is 35, and then 583 minus that is 8, and then 8 becomes 7. 7 minus 3 is 4. See, these are really drastic. There's a lot of differences here, but these are pretty similar. So I'm gonna go with this. Okay. All right. So let's take a look at the question. What does it say? Pressure, which is a dependent variable, that's pressure right here, is increasing. That means that the function is increasing, of course. So then I think an exponential regression, because we agreed with this, right? Because the differences is this part. They are far apart. All of them are very different. While the factors, meaning the numbers over here, they were very similar, are relatively close together. And then I'm going to check my answer. And of course it tells me it is correct. But that was not the end of it. And this is weird because it says then find a regression equation for the situation by using a graphing calculator. So what we gotta do is what we did in class. Okay, and so we're gonna go into Desmos and then we'll have to go ahead and insert a table. And once we insert the table, we're going to plug in all these numbers, 0 all the way through 25. There you go. 0, 5, oops, 0, 5, 10, 15, 20, and we said we're going to go all the way to 25. And for y sub 1, let's see, for 32, I need to write this down first because I don't like switching back and forth. I wish I was in class right now so then you guys could all tell me what the numbers are, but that's okay. I'm gonna go back to the calculator and put in 432 and then 454 and then 500 and then 535, 583 and 610. Okay, so once you do that, as you can see, nothing's graphing over here, and we talked about using common sense. My x value should be from where? From negative 10, because it has to be smaller than 0 but bigger than 25. So I'm just going to put like 30. All right, and then for the y-axis, has to be smaller than 432, but I always like to start with like negative 10. And then biggest number is 610, so let me just put like 700 and see if that looks good. Okay. Oh, and bam, it does look good. Okay, so I see my equation, and this is actually good enough for me. Actually, let me just zoom out a little bit. Okay, there you go. So, you know, I already know that my graph is going to go like this, kind of, sort of. So let me ask my calculator, can you please try and give me the equation using x sub 1 and y sub 1? So there you go, y sub 1 and then squiggly line. I think it's an exponential function because I tried multiplying, dividing the front by the back, and I realized that's kind of similar. Raised to the power of x sub 1. And it's a good fit. I'm going to plot the residuals to see what the difference is. Wow, it's very close. It's way better than the stuff that we were working on in class. So what is my equation going to be anyway? Y is equal to A is 430 times what's B? 1.01. Oh, okay. And we want to raise it to the power of x. But then when I plugged it in, what did I notice? They're not quite the same. I want the red one and the green one to be similar, and we talked about rounding and all that stuff, right? So let me try and figure this out a little bit. Maybe it was like 09, 08, 07, 06, 5, 4, 3. Oh, maybe it has to be bigger, like 1, 5. 1, 4. Ooh, 1, 5. 1, 4, 5. 5. Ooh, I think that's pretty close. You know what? I'm just gonna keep this one. So then I asked my calculator and it told me the equation. So because they round, that's why they say B is 1.01, but we need to try and make it accurate, so that's why we're plugging in actual numbers to get the equation. Now if you go back to the question, what did it say? It is not part of this answer, but it says, then find a regression equation for the situation by using a graphing calculator. What that means is you have to come up with an equation for that. And so what's your answer? This one right here. Y is equal to 430 times 1.0145 raised to the power of x. And of course, if this is homework, what do you have to do? You gotta take a screenshot of this side right here. And that is how you're going to give me the answer. And guess what? That's it for today. There's nothing else you have to do. And that's it. Happy learning. We're done with chapter 15. Time for a test. Goodbye.